This is Learn Programming in Java, Exceptions. Now, some courses are going to be very generic and allow you to use command line, all various IDEs. This course is going to focus primarily 100% on IntelliJ. Hey, we don't have a lot of money, so I'm going to recommend some, I think, the best value books out there for you. If you want to follow along with these books in the course, they will align very well. If you're kind of on a shoestring budget, the PDF version of the Java 5 book from Bruce Eckel, great value for the money. It's basically free. You want to get the hardcover edition, that's on Amazon. You can click on the link there. It'll take you to the Amazon website. Now, in terms of just a Java 8 book, maybe you can get one used. Maybe a friend of yours has one. Bruce Eckel on Java 8, I think the best book out there, just in general, in programming, his style, his wording, it really explains it all well. So if you're kind of like a book person, you want to read some of his chapters, read and watch my course, that's a great way to learn the language. Okay, once again, I'm Hugo Scavino, a little bit of self-promotion here. Been doing this for 30 years. I started doing Java since the beta, so it's been a long time. I primarily used what I needed to use to get my job done. I've taught this class in various countries, UK, France, tons of Fortune 500 companies out there. I've been a senior software architect with companies like DTCC, Penske, HSBC, and lots of government agencies. I've been doing this a while, basically. If you want to know more about me, check out the link to my LinkedIn page and connect with me. So let's get on to the next slide. Okay, what's required? Really, you just need JDK 8. Now, I know most of you you're running 11, 17, 21, and might be a little bit confusing, but this course really focuses on the fundamentals. The fundamentals are all in Java 8. We're not going to talk about Java 5 or anything earlier than that. Of course, you can install later or newer versions of Java 11. You can get them from Amazon, Oracle. You can also get them from open source. I'll let you Google that and figure out how to install the JDK on your environment with a Mac or PC or Linux. This course is not going to teach you how to do that. Quick Google will let you install the JDK. I recommend installing the latest version. This course is not going to go over the newer features. We're just going to go over what's fundamentally in JDK 8. Now, some courses are going to be very generic and allow you to use command line, all various IDEs. This course is going to focus primarily 100% on IntelliJ. I think it's the best IDE out there. If you've never used an IDE, IntelliJ is the one I've been using for the longest time. There's really no need to try to make this course available for all these other environments. You can port it if you want. There's Community Edition. It's free. It's awesome. Just download it, install it. So these two are the requisites. If you're not sure how to install JDK 8, please take some time. A couple of YouTube videos will get you installed right away. And then install the IntelliJ Community Edition. If you have the paid edition, great. That'll work too. We're not going to use any of those features though. So let's get that all installed and see you back in the next slide. Hey, we don't have a lot of money, so I'm going to recommend some, I think, the best value books out there for you. If you want to follow along with these books in the course, they will align very well. If you're kind of on a shoestring budget, the PDF version of the Java 5 book from Bruce Eckel, great value for the money. It's basically free. You want to get the hardcover edition, that's on Amazon. You can click on the link there. It'll take you to the Amazon website. Now, in terms of just a Java 8 book, maybe you can get one used. Maybe a friend of yours has one. Bruce Eckel on Java 8, I think the best book out there, just in general, in programming, his style, his wording, it really explains it all well. So if you're kind of like a book person, you want to read some of his chapters, read and watch my course, that's a great way to learn the language. All right, that Java 8 book though does have references to the newer versions of the language, so you can learn the basics and the concepts, but also learn some extra things while you're at it. Now, if you want to get the latest and greatest in the language, I do like the Head First Java series, Brain Friendly Guide, the 3rd edition. It does have a lot of new things in it, but really I would like to focus on the fundamentals. Once you have those concepts, the new concepts kind of build on top of that. So these are my recommendations for textbooks. They go from free to kind of medium to the latest version. leave it up to you. You want to read those chapters and watch my course, great way to learn the language. There is a big hierarchy here. Throwable is the root class for all errors and exceptions. So an error represents a serious problem that application should not attempt to handle. It's out of memory, okay? You can't handle out of memory because you're out of memory. So that's pretty much, on the way out, it lets you know, by the way, we've run out of memory. Exceptions, though, represent issues that applications can handle, and that's what we'll focus on. There are two types of exceptions. Those are checked and unchecked exceptions. So checked exceptions must be declared in the throws clause of the handle using a try-catch block. All right, unchecked exceptions are runtime exceptions that do not require explicit handling. They kind of just happen. So what are we going to do with all these types of exceptions? We're going to discuss each one and the best practice for them. Note, in C#, everything is an unchecked exception. We can discuss whether that's the best choice or not, but they decided that the whole notion of checked exceptions is just too hard, and not too hard, but just not really worth setting up your design and your signatures to be focused on exceptions. They made everything runtime. So let's see if you agree at the end. So there's kind of three things you're going to do with exceptions. You're going to throw an exception if you're generating the exception. If you're not throwing one, you're probably going to be catching one. And sometimes you'll catch it and I don't know what to do with this thing. Here's a quick statement, and I'm throwing and giving it back to the universe to see if someone else can deal with this. Here's a very simple example over here. Anyone who's been doing programming for a while has probably seen this at some point. Here's a SQL exception. I have a violation of a unique constraint, and because I'm trying to add two values to it, so my library is throwing exception. And for those of you doing C or C++ or other languages, this is coming from the database vendor, and now you have to deal with the fact that you're trying to introduce two values that should be unique into a table. Not a lot of keywords here, a lot of concepts. The try block, you've seen this in other languages and other places. I'm going to try to do something, and if an exception happens, I'm going to handle it in the catch block. Optionally, I can do something all the time, regardless whether there is an exception or not, in a finally block. This has this has not been favored, and you don't see much of this over time, and you'll see why. There's a whole other way to do this, and it's a lot better. In your signature, if you are throwing a checked exception, you'll use the throws keyword, and we'll see how that is used very soon. Here's an example of all three put together. I'm going to try something. Oops, 10 divided by 0. That's going to be an arithmetic exception. I will catch that particular exception. Now, if you remember our OO discussion about parents and hierarchy, you can just catch exception. That's kind of broad, but here I'm only catching arithmetic exception. All right, the other ones I'm not concerned about. All right, so I can do that. I can decide what level of exception I'm going to handle. And then finally, I'm always going to do this. So regardless of the math problems I may or may not have, I'm always going to do whatever's in the finally clause. The finally is being, I don't know, not so popular anymore for reasons we'll see soon. But this is the bread and butter of exception handling in terms of the code constructs. Java has so many exceptions. I really don't like creating my own exceptions. I think early on we all did because we thought we would be cool. We had this whole hierarchy of exceptions in our class, and we thought that, well, everyone would appreciate us having a very specific exception. Except one thing happened. You don't really do anything differently depending on the exceptions. You generally just log it, or you do something else. There's not a lot of extensive logic going on depending on the exception. So yes, you can have a customer exception, extend exception. Maybe you want to hold your customer ID in that exception. That's kind of cool. That way, when you get a customer exception, you know that you can get a customer ID out of it, because if it is a customer exception, it had to have been created with a message and a customer ID. All right, I mean, that's something, I guess. So just because you catch an exception doesn't always mean that you need to be the one handling it. Sometimes as an intermediary, you decide, hey, I'm going to catch the exception, do some logging, maybe some condition, but in the end, you deal with this. Here it is again. I could always throw it as a different type of exception if I really wanted to, but then you're putting in a whole lot of business logic in an area that maybe doesn't need that much logic. Maybe you should figure out why you're throwing exceptions in the first place and try to clean that up. But it's possible. Oh, everyone's favorite exception. It's the runtime exception. These exceptions happen, I don't know, at runtime. So they don't become part of your signature. They don't become part of your interface. They just happen. All right. We don't like it when it happens, and they're not checked. And we're not forcing our clients to deal with these exceptions. They can just happen. All right. So that you can inherit from that too. And if you're a C# person, that's just an exception. They're not even checked or unchecked. Okay. Now we're getting into what's the big deal about having an exception in your signature. Once it's in your signature, it's there forever, especially if you are building a library. Now, if you have some code that maybe you're not a library developer, maybe you're not building a lot of enterprise code, and you just like exceptions, good for you. But if this is code that you're going to be passing on to other teams, other companies, you really are saddling them with this exception. They always have to deal with it. It's always have to be a try catch. Could it just be a runtime exception? Does it always have to be something that I have to deal with? Ask yourself that. But this is the signature for making an exception part of your signature. Just be aware though, it's always going to be part of your signature from this point on. Versus the runtime exception. That's not part of the signature. It can happen. And maybe that gets logged, that gets handled, or doesn't get handled actually, but it's not part of your signature. Which one's better? It's going to be up to you and your business requirements. So here's kind of a sad story about Finally. Do we care about it anymore? Is there something better? I think there is, and we're going to discuss that. Finally was around when databases, network connections, and hardware specifically had to be closed. You could not leave open a sprinkler. Let's say if you had an exception, like you're trying to open up a sprinkler, you're trying to sprinkle the grass, but then something bad happens, you got to turn off the sprinkler, otherwise you're going to flood the grass, right? So you need to close memory and other hardware resources, and we almost always used to do it in the finally clause. But now we have to ask ourselves, is there a better way to do that? All right. Here's my very clunky hardware resource class. Okay. In the constructor, it throws an exception. If my hardware resource is not available, I'm going to throw an exception. Hey, I'm not available. Now, if I am available, I'm okay. You can call the start on me, and you can also call the stop. But in my documentation, I told you, hey, you got to close all the connections, and those happen in the stop method. So after you do start, make sure you always call stop. Otherwise, my connections don't get closed. All right. So just pretend this is my little class that if I'm available, great. And then you can call start on me, but always make sure to call stop, because I need to close my connections. How do I know this? Because you've been using this class in a while. It's hardware. This is how hardware works, and we're just going to deal with it. That it's very procedural code, but this is how it is. You create this hardware resource, you call start on it, and then you stop it when you're done. You better call stop, because that's how the connections get closed. Okay, here's the real clunky code that we had to use, or approximately had to use, when we were dealing with hardware, all right, or other kind of limited resources. So I'm going to take you step by step on this thing. So and it's weird code because it's just weird. All right, I'm going to try to create my hardware resource. Now, this could throw an exception, but if we don't throw an exception and we get past this, then we'll call start. which is great. But what if start threw an exception? It's like, okay, then I will throw this exception and let people know that start all devices failed, and here's the exception: the hardware device failed. Not sure if it was because this wasn't available or the start didn't work. Either way, I'm throwing an exception and something bad happened. But here's the big but: I need to stop and close the connections. So if I happen to have the hardware, if the hardware worked but the start failed, well, then I'll make sure it's not null, then I'll call stop. Weird code, clunky code, very old C style programming, if then else kind of logic. Don't like it a lot, but here's the code we had to deal with. Okay, that was clunky, but it gets worse. What if stop could throw an exception? So my hardware resource isn't null. Great. I'm going to try to call stop on that, but stop can throw an exception. Well, now I'm going to catch that exception. So this is just a little bit of madness. You got tries within tries, and you're just trying to use your resources and clean up afterwards if something bad happens. So that's the goal. But you got a lot of weird logic to attempt to get to that goal. And sometimes you could forget to use the catch because you had the finally. So you could do this try and no catch, and the code would be fine, but you completely missed the catch, and you're relying on finally. So this is a bug. So as you can see, things are just getting complicated and weird when we're dealing with limited resources and exceptions. Is there something better? Well, yes, and more and recently in the language, we now have try with resources to the rescue. So here, the try with resources definition clause, okay, it's a set of parentheses. It implements an auto-closable interface. So as long as you implement auto-closable, the language will call your close method on auto-closable, so you don't have to handle it with all this weird logic. Isn't that neat? So we are going to take it out of the programmer's hands and just say, just implement auto-closable. I, as a language, promise to call it on your behalf when something bad happens. So here's the magic. It's just one line. In the auto-closable interface, there's just one method. It's a void called close. So your method has to implement a close method, and because it implements an interface, the JVM, the language itself, will call your class's close, and as long as you close your connections or do whatever you need to do, you're good, you're solid. You don't need the finally clause anymore. Okay, here's the improvement. My closable hardware resource class now implements auto-closable. Imagine that it has a close method. Let's not worry about how it actually works. It just works, okay? It closes the connections. Now, when I use this in a try catch with a parentheses around it, this is a new try with resources, I'm going to try creating this instance and the start. So I'm trying to do two things. If either one of those throws an exception, then I'll let my people know that, hey, I threw an exception. But wait, where's the finally? I don't have a finally clause. I want my resource not close. I'll run out of memory. The sprinkler will go on forever, and the water will flood my apartment. No, because the class is auto-closable. It promises to have a close method, and in this exception handling block, the JVM will call the close on your class for you. Pretty neat, huh? And things keep getting better. You can do more than one class. All right. As of JDK 9, you can even take them out of the try catch and just put them above up here with a little semicolon. So you can open up as many resources as you need and just try them in this little order. And again, as long as they're auto-closable, which now almost all the Java classes have implemented themselves, you can implement it yourself. The close method will be called. Okay, we're going to go through a lot of exception best practices. So hold on, buckle up, and let's start with specific exceptions. I want to handle either with multiple catches or the little pipe, one exception, one specific exception, and do different things. If I'm going to do the same thing no matter what, well, maybe I don't need to handle each one, but I'm going to try to be specific with my exception handling. All right. An IO exception is different from a null pointer exception. First of all, you wouldn't be handling that. That's a runtime exception, but I just wanted to show you that you do have the ability to throw to catch per exception type. So keep that in mind. So this is something I see in a lot of folks who are starting with the language don't quite understand exception handling. All right, I'm going to do try, and then something in case something bad happens, I'll catch the exception. And you're like, what's wrong with that? This is great. This is exactly how it's supposed to work. Try catch, right? This is what you just said. The first thing I said to you is exception handling is when something really bad happens when I don't want it to happen. Instead of doing this try catch, what if I just check to see if the condition is met first? What if I make sure something bad won't happen? Okay? What if I check to make sure that the list contains the element? That way I won't have this exception. So let's try to prevent them rather than use them as kind of our error handling mechanism. Okay, real quick, if you have to use finally, great, but to try the resources is the better way to do it. Clean up your resources when you're done, especially in exception handling. Okay, it doesn't take that long to get used to this best practice. If you have generic something bad happen in your message, that's not going to be helpful. Try putting in real data, metadata that'd be useful for you, future you, to deal with these exceptions. When you look at the log, when it says, hey, that was an illegal argument. Well, what argument was it? Why was it illegal? Put it in the message itself. Okay. Sometimes you don't like dealing with checked exceptions, so I'm just going to try catch around it and whatever. I'm not going to do anything with it. Does it work? Sure. But you're swallowing exceptions, and now you're trying to debug some code and you don't know why it's not working. There's nothing in the logs. That's because you ate the exception. There's nothing happening in the catch. You're just moving along, and you might as well just not have try catching because no one knows why it's blowing up. This one, linting and other programs will catch, but boy, there's nothing more annoying than someone saying, well, you know what? The previous slide said you should do some of the exception. I'll just print it to the stack trace. No, that is just a terrible habit. We don't like doing that. Deal with the exception, log it, most likely, with a real message. Don't just do the print stack trace. I don't do exception hierarchies anymore. We're trying to keep it simple. How about so simple that you don't have them anymore? Really, really ask yourself, is there any reason why I need to have my own custom exception class versus just using the ones that are in Java? If you are going to have your own custom exceptions, keep the hierarchy simple. All right. If you're going to have checked and unchecked exceptions, make sure they are different for the right reasons. Checked exceptions is when the caller can reasonably recover from the issue. Okay, the file is full, it's an illegal name. Okay, deal with it and then maybe inform the user. Unchecked exceptions are just programming errors. You don't expect it at all. I don't expect you to every single method check for a null pointer exception. Or maybe you gave me an illegal argument exception. You were checking for illegal arguments beforehand, right? You're making sure that the object was not null, right? But if it does happen, then those are unchecked exceptions. Okay, I'm not going to sound like a broken record. You probably guessed it by now. I'm not a big fan of checked exceptions. Try not overusing them. So there you have it. There's my little homage to exception handling. I think exception handling was, exceptional at the beginning of the language. Now less important, less need for hierarchies. Better to have proactive code that prevents exceptions than to have exception ridden code. By that I mean code that has lots of exception handling. Just prevent the exception from happening in the first place. If you are going to have valuable resources, which you will, do the try with resources logic. The finally block really should go away. It's there for legacy reasons, but the try with resources is really the best way to do it. Implement auto-closable and have a close method and be done with it. In general, exception handling is very important to the language. Checked versus unchecked exceptions, that's a debate you can have with friends at lunch, but hopefully I've gone over enough of this, and I appreciate your time.
sin pensar.